Okay, in this question, we have a transformer that originally had 10 turns in the primary coil. So we are going to increase the number of turns in the primary coil from 10 turns to 30 turns. So what is going to happen to Vs and Is? Okay, first of all, we know that the secondary voltage and the primary voltage, the ratio of the secondary to primary voltages is related to the turn ratio. Or maybe a better way to write this is to write it as the secondary voltage to be equals to the turn ratio times the primary voltage. Now, since the question says that the transformer is operating under identical conditions, that must means that we do not change the primary supply, and obviously we also do not change the number of turns in the secondary coil. So if that's the case, if that's the case, then the only thing that's changed is the number of turns in the primary coil. So if the primary coil, the number of turns has increased by 3 times, then the turn ratio must have decreased by 3 times. It has been divided down by 3. That means the new secondary coil's voltage is going to be less than the original by 3 times as well. Make sense? So instead of Vs, it's going to be Vs over 3 now. Let me write the same answer here in this circuit here as well. So because the turn ratio has been divided down by 3, the secondary voltage will also be divided down by 3 because the primary voltage is still the same. Okay, what about the secondary current? Now this is the part where the question is totally unclear, because what will happen to the secondary current will depend on the resistance or the load that the transformer is operating under. So what exactly does under identical conditions mean? There are actually 2 interpretations, and I'll show you the 2 interpretations, and I'll show you that each interpretation will give us a different outcome. So the first interpretation is that identical condition must mean that we are still connecting the same resistance across the secondary coil. So it used to be R and it's still R. If that's the case, then we realize that the secondary current is going to be reduced to Is, the original one, divided by 3 as well. It is quite clear because the secondary voltage is now Vs over 3, but it's still the same load here, same resistance. So the currents through this resistor is going to be Vs over 3 divided by R. So compared to the original, which was Vs divided by R, so the secondary current is now divided down by 3 as well. Okay. If you go with this interpretation, then you are going to choose option A to be your answer. Now, there's another interpretation that is identical condition means that it's the same power load, which means we are delivering the same output power to the secondary to the load here. We are also drawing the same amount of power from the supply here. So if we are drawing the same power, that means that the primary current must be the same as before, because the power drawn is just V times I, right? So if we are maintaining the same primary voltage, then the primary current must still be the same, because we are saying that it's the same power output. So if that's the case, then we can use the turn ratio to determine the new secondary current. Very easy. The ratio of the currents is also related to the turn ratio, but it's the inverse turn ratio. So maybe a better way to write this will be the primary current is equals to the turn ratio times the secondary coil current. Alright? Or even better, I think I'll write it this way. The secondary current is the inverse turn ratio times the primary current. Okay, so under this interpretation, the primary current is still the same. The secondary coil's turns is of course the same. So what has happened is the number of turns has increased, has been multiplied by 3 times. So that means the secondary coil current is also going to be multiplied by 3 times. So instead of IS, it's now going to be 3IS, right? It's simply because the turn ratio has been divided down by 3, and therefore the current is going to increase by 3 times compared to the original case. So if you go with this interpretation, then you are going to choose option B to be your answer. Okay? I know many of you will find it quite confusing by now. Let me just push on a bit further, and hopefully it'll be clear to you exactly why there are 2 different outcomes. So let's go back to this scenario. So in this scenario, we are saying that the resistance load is the same. Do you notice that by keeping this load the same, the power delivered is actually not the same, right? The original power delivered was Vs times Is. The new power now is Vs over 3 times Is over 3. So that's actually Vs Is divided by 9 now. So the power delivered is actually reduced and is divided down by 9. If you think about it, that means the primary current must be divided down by 9 as well, because if the power output is divided by 9, then the power drawn from the supply should also be divided by 9. Since Vp is still the same as before, it must mean that the primary coil current must be divided down by 9. Alright. Now let's go to the second scenario here. So in this second scenario, we are insisting that IP is the same because we are delivering the same output power. And you see, it actually tallies. The new output power here is Vs over 3 times 3 times of Is, which means it still equals to VSIS, the original power output. So what is different here? The difference here is the load that we're connecting here cannot be R, because the current here we can calculate by Vs over 3 divided by 3Is, right? So if you think about that, that means this resistance cannot be R. It has got to be R over 9, because you take this PD, you divide by this current, that's the resistance. It turns out to be R over 9. So there are 2 interpretations here. If you insist that the load must be kept the same, then you realize the power delivered, the power drawn from the supply, will not be the same. But in the second situation, we are insisting that the power delivered and the power drawn is the same. Then in that case, the resistance that is connected to the secondary coil cannot be the same as before. So it's rather ambiguous what identical conditions really mean. So there are actually 2 possible answers. Okay, that's it. Ta-ta!